So, welcome to Mr.YantriK channel. Hello friends. Today, in a series of thermodynamics lectures, we have to understand the differences between what is microscopic and macroscopic viewpoints of thermodynamics. So, here to understand the thermodynamical behavior of any of the system or surroundings or entities, the total thermodynamic behavior has to be viewed from any of the 2 points like macroscopic and microscopic. For example, here macroscopic is considered here in this side and microscopic on the other side. So we will try to understand the differences between these two in this class. For example, let us take an example of macroscopic behavior. In a macroscopic behavior, the total entity is considered as a whole. For example, if the element is taken like this, and if we want to measure the temperature, pressure, velocity of this element, this is called a system. So system S is taken. The temperature S is considered on a whole, pressure S is considered on a whole, velocity S is considered on a whole. No individual point analysis needed to be taken in a macroscopic view. Whereas coming to the same system in a microscopic analysis, this is the total elemental system of S. So the system is composed of lot of molecules. For example, let us say these are number of molecules inside a system. So we are having lot of molecules. Say, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9 molecules are having. So we can name it as 1, 2, 3, 4. Each and every molecule is given as one name or one numerical value. For example, if the pressure is to be find out, P1 need to be find out, P2 need to be find out, and so on, P9 to be find out. And finally, the average of the pressure need to be taken in a microscopic view. And whereas the temperature also the same thing. Temperature T1, T2, T9 and the average temperature of this molecule need to be taken in a microscopic view. But the problem here is you can predict the problem. That is, in a macroscopic view, no system is taken as different entities. For example, if I have taken a rice, I have taken a rice on a whole. So if the same rice is taken as number of grains, thousands and thousands of grains, then microscopic analysis is to be imparted for the same study. So for this scenario, microscopic analysis needs more time because more analysis is to be taken and averaging, statistical averaging needs to be done. So statistical averaging need to be done in a microscopic view. More number of time is to be invested for the analysis. And uh, one more point is, if we have taken for say sophisticated equipment, there is lot of sophisticated equipment need to be used. Sophisticated equipment need to be used. So these are the main problems while going with microscopic view. Whereas while going with macroscopic view, what must be the problems? For example, macroscopic view need to be understand on a whole. So time invested is less when compared to microscopic view, and no statistical means need for the analysis. So sophisticated equipment is not needed to understand or less needed than compared to the microscopic view, and cost of the analysis is less, and here the cost of the analysis will be more. So finally, we can say that this macroscopic viewpoint of thermodynamics can be considered as classical thermodynamics, whereas the microscopic viewpoint of thermodynamics can be considered as statistical thermodynamics. So, after reading all this content, after understanding this content, we can understand that classical thermodynamics is damn easier or damn comfortable to study than statistical thermodynamics. So, in the future, in the next classes, whatever the thermodynamics that we are studying is only classical thermodynamics. It is not a statistical one. So microscopic, I mean, atomic analysis is not at all considered. We will be going to consider the total rice bowl as a single element, but not individual elements in your view analysis. So this total rice bowl is a single element, but not the individual element. So this is about the differences between macroscopic and microscopic viewpoints of thermodynamics. Next, coming to the next main concept in thermodynamics is to understand any process. For example, if a piston is taken and if you compress the liquid from, say, initial state as P1, volume 1, T1. In the total analysis, this V with a line is called volume in my classes, and capital V denotes velocity. To differentiate the differences between volume and velocity, I will represent volume like this and velocity like this. So now coming to this is P1, volume 1, temperature 1. And when the piston is moving towards the from right side to left side, say, so the pressure might be changed, volume will be changed, temperature will be changed, and the molecules, whatever it is present here, will be completely occupied this tiny space, and indirectly this process is called compression because the molecules are compressing with each other. So this is called compression. For example, if we have taken the same example like this, if we take PV diagram and from 1 to 2, the process is from 1, the initial state will be obtained and 2 will be the final state of the molecules. For example, from initial state to final state, if the fluid is compressed, indirectly the pressure will be changed, temperature will be changed, P1, T1, V1, P2, V2 and T2. For example, actually in this state the pressure increases. So I think we can take the other side. This will not be an initial temperature and this is not a final one, say, and so we need to reverse the process here. So to change it, we are compressing the liquid so that the pressure increases. So this will be the P1, volume 1, T1, and volume increases. Volume increasing might happen. So we need to assume it has different side. The total analysis for the same thing to be modified like this. So you can consider like this. This is the initial state of the molecule and this is the final state. And the pressure increases might happen. The pressure increases because of because of compression. P2, after P2 the pressure increases. From P1 the pressure is very less. Temperature increases because pressure change might happen. Volume increases because volume will be on the x direction and pressure will be on towards the y direction. So this is the initial state and this is the final state. This is the total new change. And finally, at this point, we reached, and at this point, we are finding the pressure. At this point, we are finding the pressure. Intermittently, we are not measuring the pressures, velocity. So, this point 1 and point 2 are called state points. So, what is state in a thermodynamic analysis is where the pressure is taken into consideration or at that instance of time without change in the time if we consider the uh, entity or the property that is called state functions. For example, from 1 to 2, one process is followed like this. The same wave fashion that might happen. This is 1 and this is 2. From 1 to 2, this total process, whatever it is happened, is called as process because it is a series of events, number of state functions, locus point, number of state function, the locus points can be taken as a single line and then that can be taken as a process. And for example, after reaching 2 and again the compressed liquid is again expanded like this. So the compression happened and again after a certain time we have expanded the liquid and we reached the initial state. That completes one total wave. For example, this completes the total wave like this from 1 to 2 and after from 2 to 1 the process followed. So this process is called cycle. 1 to 1 is called cycle. So this is the difference between state, process and cycle in thermodynamics. Thank you. In the next class, we'll be going to discuss some other new concepts. Thank you.